Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P1298, indicates an issue with the Electrical Load Detector, ELD circuit, specifically showing high voltage conditions. This DTC applies to Honda Civics manufactured between 2011 and 2015, indicating that the ELD could be malfunctioning or there might be issues with wiring or connections affecting its operation. The ELD plays a vital role in regulating the electrical load on the vehicle, ensuring that the battery and alternator function harmoniously. A malfunction here could lead to poor vehicle performance, battery issues, or other electrical problems. To effectively address this issue, technicians follow a detailed troubleshooting procedure to pinpoint the exact cause of the high voltage reading in the ELD circuit. It is important to gather relevant freeze data and onboard snapshots before proceeding with repairs. The main component involved in DTC P1298 is the Electrical Load Detector, ELD, which is critical for monitoring the electrical system's load. It helps control the amount of electrical power used by the engine's electrical components by communicating with the Engine Control Module, ECM. The ELD is typically located in the underhood fuse relay box near the battery, allowing it optimum access to monitor voltage levels effectively. The underhood fuse relay box contains various fuses and relays that protect components from electrical overloads or faults. Another vital component is the ECM, or Engine Control Module, which interprets signals from the ELD to manage battery and alternator operations. Proper operation of these components is essential for optimal vehicle performance, as any failure or incorrect readings can lead to a range of electrical issues within the vehicle. Several factors could trigger DTC P1298. Poor connections within the circuit can prevent the accurate reading of voltage levels, leading to a high voltage signal being registered. Loose terminals, often found in the underhood fuse relay box or at the ECM, can create intermittent electrical contact, causing similar issues. Open wires in the ELD circuit are another potential cause. If there's a break somewhere in the wiring, it can affect the ELD's ability to monitor accurately. A faulty ELD itself is also a possibility, resulting in erroneous voltage readings. Finally, a malfunctioning ECM can misinterpret signals from the ELD, causing high voltage readings. Each of these points must be examined systematically to identify the root cause of the DTC. When dealing with DTC P1298, several symptoms may manifest, indicating underlying issues. The most prominent symptom is the illumination of the check engine light, CEL, alerting the driver to a problem within the vehicle's electrical system. Poor electrical performance is another common complaint. Drivers may notice that certain electrical components aren't functioning as expected, leading to a frustrating driving experience. Battery-related problems can arise too, such as difficulties starting the vehicle or the battery draining unexpectedly. Additionally, electrical components may become unresponsive, such as power windows, radio, or lights, which could hint at a greater electrical issue beyond just the ELD. Recognizing these symptoms can help diagnose the problem early before it escalates. The first step in troubleshooting DTC P1298 begins with verifying the problem by turning the ignition switch to the on/to position. This action allows the vehicle's systems to power up and will enable the Honda Diagnostic System, HDS, to access real-time data. Next, you need to check the ELD readings in the data list using the HDS. It's essential to determine if the reading is 0.2A or less, as this value indicates normal operation for the ELD. If the reading is within this threshold, it confirms that the issue might not be persistent, indicating possibly an intermittent failure. In such cases, one should check for poor connections or loose terminals at both the underhood fuse relay box and the ECM to ensure a good voltage reading. On the other hand, if the reading exceeds 0.2A, the failure has been duplicated, allowing you to proceed to the next step. In the second step, turn the ignition switch to the lock 0 position to reset the system before proceeding. Disconnect the underhood fuse relay box 3P connector to isolate the ELD circuit. Next, turn the ignition to the on 2 position once again to allow the system to power up with the connector still disconnected. You will then measure the voltage between the specified test points, specifically between test point 1 at the underhood fuse relay box 3P connector number 3 and test point 2, which is body ground. This voltage measurement is critical to determine if there's battery voltage present. If you observe battery voltage at this point, it confirms that the IG1 ACG wire is functioning correctly, enabling you to advance to the next troubleshooting step. Conversely, if no battery voltage is detected, it indicates an issue within the circuit, prompting you to check the number B2 15A fuse in the under-dash fuse relay box. In this step, once again turn the ignition switch to the lock 0 position to prepare for the next test. To check the continuity of the electrical load detector line, begin by jumping the self-diagnostic connector SCS line using the HDS, which assists in isolating the circuit. Disconnect the ECM connector A 49P to eliminate any interference from the engine management system during this testing phase. You'll need to check for continuity between two test points. Test point 1 on ECM connector A, number 34, or nickel, and test point 2 on the underhood fuse relay box, 3P connector, number 1, ORN. This process assesses whether the ELD wire has continuity without any interruptions. If continuity is confirmed, the ELD wire is functioning correctly, allowing you to proceed to the next troubleshooting step. If continuity fails, it indicates a possible break in the ELD circuit wiring between the ECM and the underhood fuse relay box, requiring repairs. Step 4 requires checking continuity in the ground GND line related to the ELD circuit. Make sure the ignition is in the lock 0 position and the underhood fuse/relay box 3P connector and ECM connector A 49P are disconnected as specified in the earlier steps. Now, check for continuity between test point 1 on underhood fuse/relay box 3P connector number 2, black, and test point 2, which is body ground. This check will determine if there's an open circuit in the ground line, which can critically affect the ELD's functionality. If continuity is present, the GND wire is functioning correctly, allowing you to move forward with the next step. However, if continuity is interrupted, it's essential to locate and repair the open circuit within the GND wire, particularly between the underhood fuse/relay box and G301. This ensures stable grounding for the ELD circuit. In the final step of this troubleshooting process, you will substitute a known good electrical load detector, ELD, to verify whether the original component was faulty. First, ensure to turn the ignition switch to the on 2 position to power the system and prepare for testing. Following this, you should reset the ECM or engine control module using the Honda Diagnostic System, HDS, to clear any stored error codes. After resetting, perform the ECM idle loan procedure to ensure the engine operates under normal parameters. Subsequently, check for any pending or confirmed DTCs that may still be present using the HDS. If DTC P1298 appears again, This indicates that the problem lies within the ECM. In such cases, updating the ECM software to the latest version or substituting it with a known good ECM is required, followed by thorough repair verification. If DTC P1298 does not appear and the original ELD was replaced, that signifies a successful repair. Final repair verification is crucial in ensuring that all previous steps have led to a successful resolution of the problems associated with DTC P1298. Begin by turning the ignition switch to the lock 0 position and carefully reconnect all previously disconnected connectors to guarantee a seamless connection within the circuit. After all connections are re-established, turn the ignition switch back to the on 2 position to power the vehicle systems. At this point, you should reset the ECM again using the HDS to ensure that no residual fault codes are stored. The ECM idle learn procedure should also be performed to allow the engine control module to recalibrate itself according to new parameters. Finally, check for any pending or confirmed DTCs once again. If everything is functioning correctly, the DTC P1298 should no longer illuminate or appear. This step ensures the reliability of the repairs undertaken. Preventive maintenance plays an essential role in avoiding future occurrences of DTC P1298. Regularly checking all electrical connections, particularly in the underhood fuse relay box and the ECM, can prevent issues that arise from loose or corroded connections. It is also important to inspect the wiring continuously for signs of wear and tear, ensuring that there are no broken wires or exposed insulation. Alongside this, checking fuses regularly helps safeguard against electrical overloads that could affect the ELD circuit. Mechanic shops should also stay updated with the latest ECM software releases to ensure that the vehicle operates under optimized conditions. This proactive approach helps maintain overall vehicle health and minimizes the chances of error codes appearing in the future. In summary, understanding the role of the Electrical Load Detector, ELD, is key to effectively diagnosing DTC P1298. Following each troubleshooting step with precision allows technicians to systematically eliminate potential causes until the root issue is identified and resolved. The process involves checking for consistent connections, measuring voltage, and ensuring continuity throughout the relevant circuits. It also includes the important task of verifying repairs to confirm that the DTC has been successfully cleared. Ultimately, maintaining the vehicle's electrical system through regular checks and preventive maintenance will help avoid similar issues in the future, ensuring that the Honda Civic runs smoothly and reliably. These methods empower car owners to stay proactive about their vehicle health, enhancing performance and longevity. Please like and subscribe to the channel. See you next time.